In this video, we are going to solve some problems based on convex and concave lenses. An object is placed 8.5 centimeter to the left of convex lens of focal length 5.5 centimeter. So we have been given what is the object distance, which is P, which is equal to 8.5 centimeter. Focal length is given as 5.5 centimeter. Now we need to use a sign convention. Object distance is always positive, and focal length, because it's a convex lens, focal length for a convex lens is also taken as positive. It's asking us to find where will be the image form. That means what's the value for Q. So we can use the formula for thin lens, 1 over P plus 1 over Q equal 1 over F. Substitute the numbers. Use shift solve in your calculator and get the value for Q as 15.6 centimeter. You can see I have not converted the units because all of them are in centimeter, and I can write my final answer in centimeter. If I want to convert this into meter, I can divide that by 100, which will give me the answer as 0.156 meter. Okay. Now, if you're using shift solve in the calculator, you will get the direct answer Q. But if you're not using shift solve, you have to be careful because the formula is having 1 over Q, 1 over P and 1 over F. So when you find the answer, maybe you have to flip the answer to get to the correct value for Q. Okay. Now, an object is placed at a distance of 30 centimeter from a convex lens. So we have been given the object distance 30 centimeter, focal length 20 centimeter, again using the sign conventions. It's asking us to get what's the magnification of the image formed by the lens. Now, magnification formula is negative Q over P, but we don't have what's Q. So we have to get Q first using the formula 1 over F equal 1 over P plus 1 over Q. We substitute the numbers which we have got for P and F, get the value for Q as 60 centimeter. Again, remember I'm not converting the units. Then M will be negative 60 because Q is 60. So negative 60 over 30. That gives me the answer as negative 2. M magnification is negative 2. Object 5 centimeter tall. Now tall means it's giving us the object height. And object height will always be positive, plus 5 centimeter. Place 30 centimeter from the convex lens. So we have been given the object distance is 30 centimeter, which is P, and the focal length is 10 centimeter, which will be positive because it's a convex lens. How tall will the inverted image be? So it's asking us to find what's the image height. So magnification formula is HI over HO equal negative Q over P. HO is the object height and HI is the image height. So we just let's just first put the numbers which we have. So HI we don't know, HO is 5 equal negative Q over P. Now we have the value for P, but we don't have the value for Q. So again we'll go back to the thin lens formula. 1 over F equal 1 over P plus 1 over Q. Substitute the numbers to get the value for Q, which is 15 centimeter. Now we can bring it back into the magnification formula and calculate the value for HI, which is negative 2.5 centimeter. Now we get the height of the image as negative, which tells us that it's an inverted image. So the height of image is 2.5 centimeter and the image is inverted. Now let's do a problem on concave lens. The diagram below shows a concave lens. The object height is 5 centimeter. The object distance is 10 centimeter. It's labeled in the diagram. Draw 3 rays from the top of the object to locate the image. So the first ray parallel to the principal axis, it will appear to diverge from the focus. Okay. The second ray passing through optical center goes straight through it. They meet at a point where we'll form the image, which will be the virtual image. We can see that it's dotted. We will label the image as I, write that as image. Give 2 characteristics of the image. It is upright, it's virtual, and it's diminished. If the image is half the size of the object, what is the focal length of the lens? So HI, image height, is half of the object height. That means I can put the object height is 5, so 5 over 2, I get the image height as 2.5. I put the magnification formula. So why I'm putting the magnification formula? Because it's asking for focal length, so I need what's Q and what's P. So I get the magnification formula, put the numbers into it, and get the value for Q. P already I have 10 centimeter from the diagram. Q I calculated, which is negative 5 centimeter. I put it in the thin lens formula and get the value for 1 over f as negative 1 over 10. Now what I've done here is, instead of using shift solve, I use the calculator using fraction to find what is 1 over 10 plus 1 over minus 5. I get the answer on my calculator as negative 1 over 10, which I need to flip because that's 1 over f. I need to get the value for focal length, which is f. That will give me minus 10 centimeter after flipping it, which will be minus 10 centimeter. And it's negative because we have a concave lens. So that is matching with what our sign convention is. Okay, then next question is about a convex lens. Type of the lens, it's a converging or convex lens. Ray diagram, we'll get first a parallel ray passes through focus, a ray through optical center. The point where they meet, we find the image. Okay, we'll label it as image I. So we have completed the ray diagram. State the characteristics. It is real, inverted, and same size. So you can check what the size of the object was, about 3 squares on the graph grid. The image size is also 3 squares. So it has to be same size. Also, we can remember that if the object is at 2f, then the image will be formed at 2f on the other side of the lens, and the size of the image will be same. Okay, one more problem. Here it's asking you to describe the 3 properties. It's not asking you to draw a ray diagram. Just describe the 3 properties. We can see the object is between f and 2f. So we need to recall from memory that the image should be formed beyond 2f. It should be enlarged. It should be real. And it should be inverted. So this is based on our memory, how the image size and position changes, or the characteristics of image change as I move the object closer to the lens or away from the lens. For that, I have got a table here which summarizes the position of the image, the characteristics of the image, depending on where you are placing the object for both convex and concave lens. So you can memorize this table.